Okay, chapter 3.2, notes, domain and range. This is page 2. So on page 1, we talked about domain being the set of all possible inputs, the set of all x's, and the range being the set of all outputs. Some of this we can figure out based on what we know about graphs. And so if I were going to sketch this one, this is a parabola, and I know that the parent function has moved down 1. It comes down to -1, 0 on the axis, or sorry, 0, -1. Ooh. So our domain here in interval notation is all real numbers. So we're going from -infinity to infinity. Our range bottoms out at that -1. And when I plug in 0 for x, I can hit -1 for y. So we've got a square bracket there. We go -1 to infinity. That's not going to stop. Okay. B is a polynomial. It's got an odd degree. So if you think about that end behavior, we know those ends of that function are going in opposite directions. Our domain here is going to be all real numbers. Our range is also going to be all real numbers. C, we're going to focus on just the domain. And we are going to focus on the denominator. Okay? We know we cannot divide by 0. And so that's how we're going to set this up. 2 minus x cannot be 0. I can add x to both sides. 2 cannot be x. So our domain here goes from -infinity to 2, and then 2 to infinity. Basically all real numbers with the 2 removed. D, we have a radical, the square root. We know the argument of the square root must be positive. Sorry if there's supposed to be an in there. Must be positive. So that's how we're going to solve this one. Oops, back that up a minute. 5 plus 2x must be, I guess, positive's not the right word. We want non-negative. So let me change that. So it can be positive or 0, which is different than saying positive. So we're going to subtract 5 from both sides. I get 2x is greater than or equal to -5. Divide both sides by 2. I get x is greater than or equal to -5 halves. So our domain here goes from -5 halves greater than or equal to infinity. Square bracket on the -5 halves, that's going to give us our 0. Example 5 here is consistent with what we did on the front page, but we are going to take a look at this 3 different ways if we include the graph. We've got set builder notation, which you may see with the curly brackets. Curly brackets we read as the set of all x such that, and here we're just repeating the inequality. So this gives us our constraint. Okay. In terms of interval notation, -7 to 5, strictly greater than -7, that's a parenthesis. Less than or equal to 5, we've got our square bracket there, an open circle for the parenthesis, a closed circle for the square bracket, and everything in between. So again, we've got -7 less than or equal to x less than 5. So we've got the set of all x such that -7 is less than or equal to x, which is less than 5. This time that square bracket is going on the -7 part, parenthesis on the 5. We get that closed circle on the -7, the open circle on the 5, and it's everything in between. Set of all x such that -7 is less than x is less than 5. Parenthesis at -7, parenthesis at 5. Open circles in both spots. We want everything between them and not including those endpoints. The set of all x such that x is less than 5. We can go all the way down to -infinity. 5 parentheses on both ends. Open circle at 5. Arrow all the way down. Everything less than 5. Set of all x such that x is greater than or equal to 5. This time we are going the other direction. So we've got a square bracket on 5. We can include that number. We are looking for the numbers that are larger. Set of all real numbers. We've got the set of all x such that x is a member of the set of real numbers. And so now we're just including the entire number line.